اهلا بيكم اعزائي الطلبه والطالبات في حلقه جديده من برنامج مدرسه على الهواء. النهارده زي ما اتعودنا في كل حلقه هنعمل مراجعه نهائيه لماده الفيزياء لغات. طيب النهارده زي ما بنعمل كل مره قلنا هنتعرض لمجموعه من الاسئله وجدت في امتحانات سابقه وفي امتحان التجربه الخاص بوزاره التربيه والتعليم. طب تعالوا نبتدي مراجعتنا زي ما بنبتدي كل مره بقولنا the common question which is what's meant by. Let's start. So the first question in our revision is what's meant by. Let's see the first one. The first question asks me what is meant by Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction. It means that the induced electromotive force which is generated inside a coil due to the electromagnetic induction is direct proportional with the rate of the magnetic flux line which is cut by the coil and direct proportional with the number of the coil. So the Faraday's law tells us that the induced electromotive force which is generated in a coil due to the electromagnetic induction is direct proportional with the time rate by which the coil cuts the magnetic flux line, and it's also direct proportional with the number of the coil turns. So let's move to the second one. Wien's law. What's meant by Wien's law? Wien's law tells us that the wavelength of the Planck distribution curve is always inversely proportional with the temperature of the glowing body. So Wien's law tells us that the wavelength at which the peak of the curve of Planck distribution is always inversely proportional with the temperature of the glowing body. So again, he tells us that the wavelength of the peak of the curve of Planck distribution of any glowing body is always inversely proportional with the temperature of this body. As an example, we know that the temperature of the body is about 6000 Kelvin, so it has a high temperature. So most of the radiation which comes from the sun has low wavelength, or the peak of the curve is found in the low wavelength range, which is the visible spectrum range. Let's move to number 3. What's meant by the current division equals 0.99? We know that the current division is the ratio between the current which passes or comes outside the collector divided by the current which passes to the emitter of the transistor, and it's equal 0.99. So it means that the ratio between the collector current and the emitter current is 0.99. So let's move to point number 4. What's meant by the magnetic flux density at a point is 0.2. Magnetic flux density at a certain point is 0.2. We know that the magnetic flux density is the ratio between the magnetic flux and the unit area which is affected by this magnetic flux. So we can say that it means that the magnetic flux at a unit area is 0.2 Newton over ampere meter. Point number 5. The dynamic equilibrium in a pure silicon crystal. Dynamic equilibrium in a pure silicon crystal. What's meant by this? We know that the silicon crystal at the normal temperature, it is insulator material because there is no bonds are broken down. But when I increase the temperature of this silicon crystal, many bonds are broken down and many free electrons are formed inside the crystal, which help in increasing its conductivity. So by increasing the temperature, the number of the broken bonds increases also, and the number of the freed electron inside the crystal increases also. So what is meant by the dynamic equilibrium state? It is the state at which when or at a certain temperature a state is reached is called a dynamic equilibrium state, where the number of the broken bonds equal to the number of the bonds which are recombined again. So it is the state where the number of the broken bonds are equal to the bonds which are recombined again. So let's see the answer again. It is the state which is reached by the pure silicon crystal, so that the number of the broken bonds, okay, is equal to the number of the recombined bonds again. Okay, let's move to another question, which is choose. Let's see. He said that the ratio between the photon's momentum to its mass is equal. So he wants me to do what? He wants me to divide the photon's momentum by its mass. Okay. So the photon momentum divided its mass. So if I divided the linear momentum of the photon by its mass, we know that the linear momentum of any body is the mass of the body times its velocity. Okay, if I divided it by the mass, this will give me what? The velocity of the light. So if I divided the photon linear momentum by its mass, the result will be the velocity of the light. So the answer will be the velocity of the light. So again, the answer will be the velocity of the light. So let's move to another question. Okay, let's move to another question and let's look. He said that the dark lines which appears in the spectrum of the sun is a kind of emission spectra, absorption spectra, or continuous spectra. So again, the dark lines which appears in the continuous spectrum of the sun are considered emission spectra or absorption or continuous spectra. So let's first know what is meant by the dark lines which is formed in the continuous spectrum of the sun. These dark lines are called the Fraunhofer lines. Fraunhofer lines result when the gases which surround the sun absorb some wavelengths which comes from the sun. So I think it's a kind of, yes, absorption spectra. So the answer will be Fraunhofer lines, or the dark lines which appear in the continuous spectrum of the sun are called or a kind of the absorption spectra. Let's move to another point. Okay, let's look at this circuit. In this circuit, he showed me a certain circuit which contains a battery, resistance, and variable resistance. And there is a voltmeter which is connected between the poles of the battery and the poles of the variable resistance. And he asked me, what will happen to the reading of the voltmeter when we increases R? Okay, do you think what will happen? Let's see. Okay, let's see that we have a voltmeter which is connected parallel to the battery and to the variable resistance. We know that the battery has a certain resistance which is R small and the other parts of the circuit, and the potential difference of the electromotive force of this electric source is VB. What is the reading of the voltmeter? The reading of voltmeter will be VB minus IR plus R small. So this is the reading of the voltmeter, which is R dash, or the variable resistance. He asked me what will happen if R variable increases. Okay, if the variable resistance increases, this value will be increased. So the reading of the voltmeter will be decreased. So if the variable resistance increases, the reading of the voltmeter will be decreased, because the internal or the resistance plus the internal resistance, or the amount of the resistance between the two poles of the voltmeter is increased, so that the reading of the voltmeter will be decreased. Oh, let's turn again to our slides. Okay, so the answer will be, it will be decreased. Okay, again, so the answer will be, it will decreases. So the reading will be decreases. Let's move to another question. Let's see if the frequency of the emitted photons from the glowing body increases. So their number, okay, if the frequency of the emitted photon increases, their number will be, okay, by increasing the frequency, the energy of the photon will be also increased. So their number will be decreases. So the number of photons decreases by increasing their energy. Let's move to another question. In this question, he tells us, okay, a conductor of uniform cross-section area, its length is 20, and its resistance is 108 ohm. Another conductor of the same material, so they have the same resistivity, has length 5 meter, and the cross-section area of it is 3 times the cross-section area of the first conductor. So find the resistance of the second conductor. Okay, let's try to solve this. He tells us that R1 equal 108 ohm and L1 equal 20 meter, and they are made of the same material. This means that they have the same resistivity, and the area of the second one is 3 times the area of the first one, and the length of the second one equal 5 meter. So can we find R2? Okay, we can say that R1 over R2 equal L1 times A2 L2 times A1. So L1 over A1 L2 over A2. طب R1 equal 108. L1 is 20. L2 is 5. And the area will be 3A, while the area of the first one will be A. Because A2 equals 3A1. So A2 could be 3A and A1 could be A. Cancel this by this. So by making a cross, R2 will be equal 9 ohm. So the answer will be 9 ohm. So let's look at the answer again. It will be 9 ohm. Let's move to another one. The ratio between the photon energy after collision to its energy before collision, okay, is in Compton effect. So he wants to find the ratio between the energy of the photon after collision to its energy before collision. We know that in Compton effect, the energy of the photon after collision will be decreased because most of its energy will be transferred to the electron by which the photon is colloided. So the answer will be less than 1. Why less than 1? Because its energy after collision will be decreased or less than the energy of the photon before collision. So why the energy of the photon decreases? Because we have said that after collision, some of its energy will be transferred to the electron. So again, why the energy of the photon is decreased because some of the energy of the photon will be transferred to the electron by which the photon is colloided. So the answer will be less than 1. But let's move to another question. Let's see. The second question, he tells us in Balmer series. Okay, Balmer series of the hydrogen spectrum. Okay, which of these answers will give us the highest wavelength? Okay, so the highest wavelength in Balmer series result from transferring the electron between which of the following two levels. Okay, he says that he wants the highest wavelength which is equivalent to the lowest energy. So highest wavelength means that the frequency and the energy will be the minimum or the lowest energy. So the lowest energy will be when the photon or the atom transfer from energy level number 3 to energy level number 2. And we must remember that most of the spectrum of Balmer series is found in the visible spectrum range. So it will be, the answer will be from energy level 3 to energy level 2. But if you want the lowest wavelength, it means the highest energy, so that he can fall from energy level number 7 to energy level number 2. Let's see. The photon of laser are considered from, photon of the laser is considered from, yes, I think it's, yes, right, it's from the linear emission spectrum. So laser rays is a kind of linear emission spectrum. But what is the scientific idea of the laser ray? It is the stimulated emission. So it is a kind of the linear emission spectrum. But let's see. Okay, the other point is the linear momentum of any photon is found from relation. He wants the linear momentum. It will be answer number A. The linear momentum result from the dividing of Planck's constant by the wavelength. طب, what do you think the name of this relation? This relation is called the Pauli relation, and this is a very important relation. This relation is used to find the wavelength which is of the wave which is accompanied with the motion of electron beam in electron microscope or electronic microscope. So the Pauli equation is a relation which helps us to find the relation of the wavelength of the wave which is accompanied with an electron beam which moves in the electronic microscope. But let's move to another question. Let's see. Okay, let's look. When the electric current passes in a conductor increases, so its resistance will, so we have a conductor carrying an electric current. But what do you think will happen to its resistance if I increasing the electric current which passes in it? Okay, but let's know what are the factors which affect the resistance of an electric conductor. The resistance, okay, let's see the law of the resistance. This is the law of resistance. We know that the resistance equal resistivity, length, area. So the resistance is affected by type or direct proportional with the length of the conductor, inversely proportional with the area of the conductor, and it depends on the resistivity of the material, which means the kind of the material, and it's also direct proportional with the temperature. By increasing the temperature, the resistance of any conductor will increase. So by increasing the electric current which passes in it, the resistance will be constant, will be the same. Why it will be the same? Because the resistance of any conductor depends on the length, the area, or the dimension of the conductor, and depend on the type of the conductor and the temperature of the conductor. So it isn't affected by the electric current which passes through it. So the answer will be the resistance will remain constant. But let's move. So the answer here will be constant, remains constant. Let's move to another one. The ratio from dividing the electromotive force of the effective electromotive force equal. So he wants to find the ratio between divided the electromotive force maximum to the electromotive force effective. But let's remember the law. We have said that the electromotive force effective equal electromotive force maximum if I multiply it by sine angle 45. So if I want to divide it, the electromotive force maximum by the electromotive force effective, the answer will be 1 over sine 45, which will be, okay, root 2. So the answer will be root 2. So our answer will be root 2. So the answer, as we know, it will be root 2. But let's move to another question. Okay, let's see this question. In helium and neon laser device, the internal pressure of the glass tube that produces the laser is equal. Okay, this is a very important question. The helium or in helium and neon laser device, the internal pressure of the glass tube that produces the laser is 0.6 millimeter mercury. So this is the pressure of the laser device or neon helium laser device quartz tube. Okay, let's move to another one. The measuring unit of the magnetic permeability of a medium will be, okay, he wants to find the measuring unit of the magnetic permeability of a medium. But let's see. Let's write the law and try to find the measuring unit. We know that B equal permeability I over 2 by D. This is the law to find the magnetic flux density which result around a wire due to passing of a current through it. So he wants the unit of the magnetic permeability. Okay, let's make a cross. So the magnetic permeability will be B times 2 pi D over I. B will be Tesla. 2 pi has no measuring unit. D will be meter over I, which is ampere. So this is the measuring unit of it. Tesla meter square over ampere. But he doesn't give me this unit. We know that Tesla is also Weber divided meter square. So meter and Weber divided meter square. And ampere will give me Tesla. So this ratio will be Tesla. Tesla is Weber over meter square. So by cancelling one of the 2 meters out, downward by one of the meters upward, the answer will be Weber divided meter ampere. So this will be the measuring unit of the magnetic permeability. So the answer will be Weber over area over ampere times meter. So the answer will be Weber over ampere times meter. طب let's see. Let's move to question which is called problems. Let's see the problem that we have. Okay, this problem is found in an previous exams. Let's see. Give me an electric circuit and he want the reading of the voltmeter and the value of the resistance R2. طب let's move. Let's draw this circuit in our paper and try to answer it. Okay, let's see. This is the ammeter and another resistance is connected to it in parallel. This is R2 carrying current I2. This is R1 which is equal 16 ohm carrying current I1 which is 0.5 ampere, and they are connected with another resistance R3 in series. And this is the voltmeter which is connected to it, and they give us that R3 equal 4 ohm, and both of them are connected to a source of voltage of 12 volt. So again we have 3 resistors, R1 which is 16 ohm, R2, and as we can see that R1 and R2 are connected in a parallel connection, and both of them are connected with R3 which has the value of 4 ohm connected in series with R3. So R1 and R2 parallel and they are connected in series with R3. So he wants the reading of voltmeter. He wants the reading V. He tell us find the reading of the voltmeter. Okay. R1 and R2 are connected in parallel, and we know that the voltage across R1 and the voltage across R2 is equal because they are connected parallel. So when 2 or more resistors connected in parallel, the voltage across them is equal, as we know. So V1 must be equal V2, which must be equal the voltage across all these boxes. So V of this box must be equal V1 must be equal V2 because they are connected in parallel. Okay, let's find V of the box, which is V1 plus V1 or V2. Can we find V2? No, because we doesn't have R2 or I2, but we can find I1, R1. So 16 times 0.5, 16 times 0.5 will give us 8 volt. So the voltage of all of these boxes is 8 volt because V1, which is R1 times I1, 16 times 0.5 equal 8. So V1 equal 8 volted or 8 volt, V2 equal 8 volt, V of all these box is also equal 8 volt. But we know that this box is connected in series with this resistance R3. So we can say that V total must be equal V of the box plus V3 because they are connected in parallel. So V3 equal V total minus VB, which is equal 12 minus V box, which is 8, which will be 4 volt. So the voltage across resistance 3, or the reading of this voltmeter, will be 4 volt. So the voltage here is 4, the voltage across this box is 8, 8 plus 4 will be equal 12, the voltage across all of the circuit. طب let's see the current which pass in it. It will be V3 divided R3, which means 4 divided 4, so will be 1 ampere. So the current here will be 1 ampere. And we know that this 1 ampere will be divided. So here we find number 1. He wants us to find the voltage, which is 4 volt. The reading of this voltmeter will be 4 volt. And the current which passes here will be 4 volt divided 4 ohm, which will be 1 ampere. And this 1 ampere will be divided in these two branches because they are parallel. So here there is 0.5 ohm, so V2 must be also equal 0.5 ampere, because 0.5 plus 0.5 equal 1 ampere. طب okay, so I2 equal I1. Both of them are 0.5. So R1 must be equal R2. And this is the second thing he wants to find. He said find R2. R2 will be equal also 16 ohm. So R2 will be 16 ohm because they carry the same current. R2 must be also equal 16 ohm. So this is the answer of our problem. This problem is found or is put in one of the previous exams. Let's move to another problem in our lesson. Let's see another one. Okay, it's a good problem. Let's read it. He said a galvanometer, the resistance of each coil is 40 ohm. Okay, I think it's good. So we have a galvanometer. The resistance of each coil is 40 ohm. Okay, and it's connected to a certain resistance of 20 ohm in parallel. Okay, so its resistance is 40 ohm. And the resistance which is connected in parallel to it is 20 ohm. Okay, find the resistance needed to be connected to it in parallel also to allow the passage of 0.2 of the real current in the coil of the galvanometer. Okay, so we want to find the other resistance which is connected parallel so that the current which passes in the coil of the galvanometer will be 0.2 of the total current. Okay, let's try to solve it. So he said that we have a galvanometer. Yes. Rg of the galvanometer is 40 ohm. And it is connected to a resistance 20 ohm. Okay. So he asked us find the value of the resistance which if it is connected parallel to both of them. So there is another resistance connected in parallel. He wanted to find the value of this resistance which if it is connected in parallel, Ig will be equal 0.2 of the total current. The current which pass here, which is Ig, must be equal 0.2 of the total current maximum which enters the circuit. Okay, let's find the shunt resistance. Shunt resistance equal Ig, Rg, I minus Ig. So Ig equals 0.2 I times Rg, which is 40. And here will be I minus 0.2 I. So it will be 0.2 I times 40 divided by 0.8 I. We can cancel I and I. So the shunt resistance will be equal 0.2 times 40 divided by 0.8. So the shunt resistance will be 10 ohm. So the value of R1 and R2 must be 10. Okay, R1 and R2, their value must be equal 10, which must be equal the shunt resistance, which is connected in pair to RG. Okay, this is R2 is 10, so we can say 1 over R shunt must be equal 1 over R1 plus 1 over R2. So 1 over 10 must be equal 1 over 20 plus 1 over R2. So that we can find that R2 must be equal 20 also. So that R2 must be equal 20. Because 20 parallel to 20, the resistance will be equal 10. So first we find the shunt resistance RGI minus IG, which is equal 10. So the total resistance of R1 and R2 must be equal 10. And this is equal 20. So there is another resistance which is R2 connected to parallel. So it must be also equal 20, because 20 parallel to 20, R of them will be equal 10. So R2 must be equal 20. Let's move to another question. Let's see another question. The second question is also a problem. Let's see. Okay, it is a graph problem. I think it is one of the most important question and one of the most easy question, because you can solve it easy. Okay, let's see. He give me a table between, this table represents the relation between the magnetic force affect a straight wire and the angle between the wire and the magnetic field. Okay, and he says that we have a metal wire. The length of this wire is 1 meter. Okay, carrying a current of 2 amperes. Okay, found in a magnetic field has density B. And the table illustrates the relation between, so this table explains the relation between the magnetic force and the angle between the magnetic field and the wire. Let's see. He said that when sine theta equals 0.1, the force will be 0.2. Okay, and when sine theta 0.2, the force will be 0.4. And when sine theta 0.3, force will be 0.6, and so on. So the first question he asked us, I think, to draw the table. How can we draw this table in form of a graph? Okay, look at the table again, write the table in your notebook, and let's draw the table together. So the first question, this is the table. Okay, write the table on your notebook and let's move. The first question he asked me, he wants me to draw the graph or draw the relation between the force. Okay, and this is very important. The force is Newton's, is found in the vertical axis. So the force must be in the vertical axis, which means y-axis, while sine theta in the horizontal axis, which is x-axis. Okay, and then he wants me to find the force affecting the wire when it becomes perpendicular to the magnetic field. Okay, so first he wants me to draw. Second, he wants to find the wire, and he wants to find the magnetic flux density. Okay, so the first point in our graph, we must write or draw sine theta in x-axis, and we must draw the force in y-axis. I recognize that sine theta increases by 0.1 in each step. So I made a graph for it where sine theta increases by 0.1 for each step. So 0.1, 0.2, 0.3 until 1. And the force, I found it increases uniformly by value of 0.2. So each step in the force axis or in the y-axis will be represented 0.2 degrees, 0.2, 0.4, and so on. First, from the table, we have found that at sine theta equals 0.1, the force is 0.2. And when sine theta is 0.2, the force is 0.4. And 0.3 sine theta, the force will be 0.6. So I make a point at each step. 0.4, when the sine theta is 0.4, the force will be 0.8. When sine theta is 0.5, the force will be 1. And when sine theta is 0.6, the force will be 1.2. Okay, so I draw the points as you can see, which represent the relation in the table. Then I will make a straight line connecting them together. So I found that there is a straight line, or the graph takes the shape of a straight line. This means what? This means that the relation is a uniform relation, because the straight, or the graph of it, is represented in form of straight line. So I answer the first point, which is draw the graph. So I draw the graph first. Then I try to find the force when the wire is perpendicular. But let's see. Okay. So he wants me to find the force when the wire is perpendicular on B. When the wire is perpendicular on the magnetic flux density, or in the magnetic field. This means that theta equal 90. So he wants me to find the force when theta equal 90, so sine theta equal 1. He wants me to find the force when sine theta equal 1, because theta equal 90. We can find it from the graph, or as it is a uniform graph, we can make a cross multiplication. We can make a cross. We know that the force is 0.6 when sine theta is 0.3. So what will be the force when sine theta equal 1? So we can make a cross, so the force will be equal to newtons. So the force will be 2 Newton. Then he wants us to find B. We know that the law is FBIL sine theta. So P over IL sine theta. If the force is 0.6, I is 2, sine theta is 0.3, and we know that the length of the wire is 2, so the answer will be 1 Tesla. So B is 1 Tesla. So first I found the force, which is 2 Newton. I can find it by making this cross, or I can find it from the graph. And I found B by this way, by dividing the force by the current and the length and sine theta. So I found point number 1 and point number 2. But let's move to the second problem in our revision. Let's move again. Let's look at the second problem. Okay, the second problem is also a graph. But this graph is one of the most important graphs. This graph is found in many exams. What about this graph? This graph is a graph which represents the relation between, okay, the induced alternative current through half cycle of AC dynamo. So this graph represents the relation between the current intensity which is induced in a coil of a dynamo and the time. Okay, he gives us that the current is measured in ampere, while the time is measured in milliseconds. This is very important. The time here is measured in milliseconds, not second. And we found the graph I equals 0 when the time equals 0, and I began to increase. By increasing the time, then it decreases again. But let's draw. So first, can you draw this table in your notebook now? Okay. Okay. After drawing it, let's try to draw the graph together. طب let's see what he want. First he want us to draw the graph where the time is found in the horizontal axis, which is x, and the current in the vertical axis, which is y. Then, after drawing, you want me to find the effective value of the current intensity induced in the coil, and then find the periodic time. So he first want me to draw the graph. Second, he want me to find the effective value of the current, and then find the periodic time. So let's draw this graph. Okay, in this graph, I make a uniform space between the time, which is 1 degree or 1 millisecond between each 2 points, and in case of the current, I make a space of 1 ampere between each 2 points. Let's see. When the time is 0, the current was also 0. When the time is 1.3 seconds, the current becomes 3.8. When the time is 2.5, the current becomes 7. And with the time is 3.8, the time becomes 9.3. And when the time becomes 5, the current becomes 10 ampere. And then again, when the time turns to be 6, the current will be 9.3. And when the time is 7.5, the current will be 7.2. And when the time is 9.2, the current is 3.8. And when the time is 10 milliseconds, the current equals 0. Okay, so this graph is represented by a curve, as you can see. This curve increases at the first 5 seconds, then the curve began to decrease in the last 2 seconds. Let's connect this point together. Okay, but what can we recognize from this curve? The first one, can you see the maximum current reached by the dynamo? What is the maximum current? Yes, it's 10 ampere. So we can consider 10 ampere as the maximum current which is reached by the AC dynamo. This graph represents how many parts of a cycle or rotation of a dynamo? I think this graph represents half cycle of rotation of a dynamo. So from this graph we can conclude that 10 ampere is the maximum current induced inside the AC dynamo, generated inside the AC dynamo, and 10 milliseconds is the time needed by the dynamo to make half cycle. So 10 milliseconds is the time needed by the AC dynamo to make half cycle. So we have drawn the curve or the graph. Let's move to the points which he give us and write what we have got. Okay, from this graph we can conclude that the maximum current I max is 10 ampere, and the time needed to make half cycle is 10 milliseconds. From the graph I recognize this. The maximum current is reached, which is 10 ampere, and the time taken by the coil to make half a cycle is 10 milliseconds. Let's see. He first wants the effective value of the current intensity. So he wants I effective. Okay. He wants I effective. We know that I effective equal I max times 0.70. So I effective will be equal 10 times 0.70. So I effective will be 7.7 ampere, 0.07 ampere. So this is the first point he wants from us. The second point, he wants to find the periodic time, or the time for one complete cycle. We have said that 10 milliseconds is the time taken to make half a cycle. The periodic time or the time to make one complete cycle will be, okay, 2 times the time taken to make one cycle. So it will be 20 millisecond, which is 0.02 second. In this graph, you can ask me also find many things, like find the frequency. Okay, I got the periodic time, which is 0.02. So I can find the frequency, okay, by dividing 1 over the periodic time. So the frequency can be get by dividing 1 over the periodic time, which I think is equal about 50 hertz. Okay, and he can ask me find the angular velocity, which is 2 pi f. He can ask me to find many things, and he asked me find I after certain instant or after a period of time. So I think the graph questions or problems is one of the important questions in our exam. They can be easy solved, and you can solve it in an easy way, and you can get many grades from it. But let's move to another problem question. Okay, another problem which is, okay, let's see. It is a logic gate problem. It is a logic gate problem. Okay, he gave me a certain logic gate. Okay, we can see that this electric circuit contains 3 inputs, A, B, and C. So this electric circuit has 3 inputs, A, B, C, and has 1 output, which is D. Okay, then he gave me, okay, look at the circuit again. 3 inputs, A, B connected to OR logic gate, and C, which is connected to NOT gate, and there is a D, which is 1 output. Then he gave me a table, as you can see, and if he asked me if the input A is 1, input B is 0, and the input C is 1, and he wants me to find the output D. So let's solve it. Let's try to solve it together. So he said that input A is 1, and input B is 0. Input C is 1. So let's move to input A and B. Input A is 1, input B is 0. They are both moving to OR gate. So OR has 1 and 0. What will be the output? The output will be 1. Because the OR gate needs just 1 input to get 1 output. Let's move to input C. So 1 moves to the NOT gate. The output will be 0. Because you know that the NOT gate is called the inverter, because it inverts the input. If the input is 1, the output will be 0. If the input is 0, the output will be 1. So 1 and 0. 1 will move to AND gate, and 0 will move to AND gate. So the 2 inputs which reach the AND gate will be 1 and 0. So what do you think will be the output? The output will be 0. Because the AND gate needs 1 input, so that the input becomes 1. But the answer here will be 1, because one of the inputs is 0. Okay, let's move to the table. So the answer will be equal 0. Let's move to the table again. So the answer will be equal 0. So we have answered the first point. Let's try to answer the first point. He said that the input A becomes 0, input B becomes 1, and input C becomes 0. So again, input A is 0, input B is 1, and input C is 0. 0 and 1. So the 2 inputs to OR gate will be 0 and 1. So the output will be 1. The input C moves to the NOT, which is 0. So the output from the NOT will be the inverter. It's called the inverter because the output will be the opposite of the input. If the input is 0, the output will be 1. So we get 1 in this branch and another 1 in this branch. So the 2 inputs in the AND gate will be 1 and 1. So what do you think will be the output? Yes, the output will be 1. So the output will be 1. That's good. Let's move to the table again. So the answer of this part will be 1. So the answer of this part is called 1. طب and then he gave me two inputs. A is 1, B is 1, and C is 0. What will be the answer? طب let's move. He said that A is 1, B is 1, C is 1. So we have three inputs, A, B, C, 1 and 1 and 1. The two inputs for the OR gate will be 1 and 1. So the output must be 1. طب let's see for C. So sorry, C, he said that C equals 0 gate. So if the C equals 0, the output will be equal 1, because when the input is 0, not invert it into 1. So 1 and 1 will be the two inputs for the AND. So 1 and 1, the output will be 1, because we have said that AND needs one inputs to get one output. Okay, let's move to the table. Let's see the table. So the answer will be, let's move to the table again. The answer will be, yes, it's 1. طب part number 4 of our table, all of the inputs is 1. A is 1, B is 1, and C is 1. So all the inputs are 1. A is 1, B is 1, and C is 1. So the two inputs for the OR gate will be 1 and 1. So the output will be 1. طب the input for the NOT gate is 1. So the output, we have said it is called inverter. It will invert it into 0. So 1 and 0. 1 and 0, the output will be 0. It will be 0. So here is 1 and here is 0. So the output is 0, because we have said that and need one input to get one output. While it is 1 and 0, no, the output will be equal 0. Let's see the table again. The answer will be 0. Let's see the table. The answer will be, let's move to the table. The answer will be 0. Okay, this is one of the important questions. How can we find or complete the truth table of any logic gate circuits? Let's move to another problem. Okay, there is another question here. Mention the rule or the way by which we can determine. So he asked us to mention the rule or the way which we can use to determine first the direction of the motor coil rotation. He wants me to find the rule by which you can determine the direction by which the motor of the coil rotation. The answer will be Fleming left hand rule. So Fleming left hand rule help us to determine the direction by which the coil is rotated. If he asked me what is the function of Fleming left hand rule, it is used to determine the direction of the magnetic force which act in any straight wire, or it is used to determine the direction of the torque which affects the electric motor. طب point number 2, find the rule by which you can determine the direction of the current induced in a dynamo coil. He wants me to determine the direction of the current induced in the dynamo coil. It will be Fleming right hand rule. So Fleming right hand rule is used to determine the direction of the induced current in a coil or a straight wire, or we can use Lenz rule, but the Fleming right hand rule is the most common one. It is used to determine the direction of the induced electromotive force or current inside a straight wire or inside a coil. Number 3, the polarity of a diode. How can we determine the polarity of the diode? Polarity of the diode means how can I find the two poles of the diode? Okay, this can be found by using an ohmmeter and a circuit. First way, I will connect the diode. I will connect the diode to the source of the electricity. If the resistance turns to be 0, this must be backward connection, so that if this P plus and this is negative, this will be negative and this will be plus, or P and N, because it is a backward connection. So that the resistance means here maximum. Sorry, the resistance, if the resistance is maximum, it will be backward. طب what will happen if I found that the resistance equals 0? It will be forward. Forward means if this is P plus and this is minus, this will be plus also, or P, and this will be N. So by using an ohm meter and the electric circuit, if I found the resistance is maximum, this means that it's backward connection. So the positive pole of the battery must be connected to the negative side, or the negative part, or the negative crystal of the diode, and the negative side of the battery connected to the positive side of the diode. While if I found the resistance equals 0 and the current is maximum, the connection is the forward connection. This means that both of the positive sides of the diode and the battery is connected together, and the negative side of the diode is connected to the negative pole of the battery. So this is the way by which we can determine the polarity of the diode, by connecting it to an ohm meter and connecting it to a battery and ohm meter, and so that we can find its polarity according to the resistance. And by this way also we can comparing between the diode and the ohmic resistance. How can we do that? Okay, if we connected the resistor or the normal resistor by the same way to an ohm meter and electric circuit, its resistance wouldn't be changed, or the resistance will be constant. However, the way of connection, it doesn't change like the diode, while the resistance of the diode could be changed according to the way of connection. So this way is used to determine the polarity of the diode, or could be used to comparing between the normal diode and the normal ohmic resistance. And we must know that, the diode is used in rectification process of the current. What is meant by rectification process? Rectification process means that it can change the direction of the AC current into unidirection current. طب شكرا لكم اعزائي الطلبه والطالبات. النهارده احنا عملنا مراجعه مهمه جدا، اتعرضنا ازاي نحل مسائل الجراف، اتعرضنا لمجموعه مسائل مهمه جدا جدا. اتمنى انكم تكونوا استفدتوا. ادعي ربنا يوفقكم في الامتحانات الجايه، واقول لكم شكرا، ومع حلقه جديده مع برنامج مدرسه على الهواء. شكرا.